In this video we're going to look at how to find the nth term of an arithmetic sequence. So first of all we need to know what is meant by the term arithmetic sequence. So this is a sequence which goes up or down in equal steps from one term to the next. And in order to define this we use A as the first term in a sequence and D for the difference between each of the terms in the sequence. So in example 1 here we have an entirely algebraic and general form of an arithmetic sequence. So the first term you can see is A, so then we add D to get the second term, add another D to get the third term, add another D to get the fourth term. So how about finding a formula for the nth term? So we're going to use the same notation as we did earlier to have us UN being the nth term. And let's look at how this is made up. So each term in the sequence has an A, so we know the general term is going to have an A, and it has a number of D's. So the first term has no D's, the second term has 1, the third term has 2, the fourth term has 3, and so on. So the number of D's is 1 fewer than the number of terms. And that gives us this, which we can then use as a formula to help us solve other problems. So if we look at question 2, let's find the nth term of this sequence. So let's find the values of A and D. So A is a value of 5, D is a value of 4, which is a common difference. So UN is equal to A plus n minus 1 D. And I could leave this in this form, or I could perhaps simplify it into a slightly nicer format. So UN is 5 plus 4n subtract 4 is therefore 4n plus 1. And when we've got a sequence which is descending rather than ascending, it doesn't make any difference. So the start term is 16, and the common difference here is negative 3, as that's what I have to do to each term to get the next. So UN is equal to A added to n minus 1 D, and I'm going to expand the brackets. And then finally I'm going to simplify it, so I have 19 subtract 3n, and I have written an expression for the nth term of this particular arithmetic sequence.